Greetings, M Squared here, and today we are going to talk about the law of cosines. And you will definitely need a scientific calculator, so if you don't have one, make sure you go get one. So we're just going to talk about why there are three things here. So you'll see that they're really similar, and you'll see that that's kind of the Pythagorean theorem. Remember a squared plus b squared equals c squared kind of thing? And so all of these you've seen kind of before. I don't know if you know what the cosine of 90 is, but if this was a right triangle, which we've said you can only use Pythagorean theorem with a right triangle. If you know that the cosine of 90, what the cosine of 90 is, if this was a right triangle, right here, angle C would be 90, the cosine of 90 is 0. So if you were using this with a right triangle, the reason we say you could only use it with a right triangle is because all of that would be gone, because those would be 90. And 0 times anything, so you'd just be left with the Pythagorean theorem. So it kind of has the roots in a right triangle Pythagorean theorem, but we're going to use it for non-right triangles. So it's important to know that little a is always opposite the angle A, that little b, lowercase b, is always the side opposite angle B, and that side C is always the side opposite the angle C. Notice that if you have a little a out here, big A here. So side opposite this angle, this side is opposite this angle, this side is opposite this angle. Those are really important to notice. And then the a squared, b squared, those are the other two sides. And notice that a and b are the same here. A and c and b and c. That's really, I mean, if you have to memorize it, that's really important to kind of notice the differences in the formulas. So side opposite angle, and then these guys are the same in the minus 2bc. You got to kind of just memorize that. Okay, let's just do some problems. So here we're supposed to find BC, so let's just call that little a. And in order to use law of cosines, we need to have that side angle side thing going on. So we're trying to find the side opposite angle A. So that's this formula, a squared equals, and then it's the other two sides squared, the sum of those, and then it's minus 2 times those two sides times the cosine of A, which in our case is 57. So in this case, when you're not finding the angle, when you're finding the side, you've got all of that stuff. You can put it all in your calculator all at once. It gets tricky when you have to start moving things over if you had to find one of these other sides because they gave you A. And then you got to know that this is all being multiplied, so you have to get rid of those first. We'll talk about that later. But anyway, let's just put it all on our calculators. 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 57. So we just put it all in our calculator at once. Now here is what you must remember. 5, 7, da 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 da. It gave me a squared. That's the formula, a squared, but I don't want a squared. I want a. So I need to square root that a squared. So I'm going to say second square root, and then I'm going to say second answer, because the answer, whatever the answer I just asked it for, is going to give it back to me. And you can always double check. So let's round to the nearest tenths, because it says to round to the nearest tenths. So that would be 7, 6. 6 takes the 7 up to an 8. So 8 squared is 64, so yeah, that's pretty close. 9 squared is 81, so I know that squared it should have been between 64 and 81. So you always want to just double check in case you made a mistake. Alrighty, let's try another one. So I like to label my side. So angle B was 92 and A is 13. Again, you see that side angle side thing going on. So now we're looking for B. So our formula says B squared is equal to 8 squared plus 13 squared minus 2 times 8 times 13 times the cosine of 92. Okay? Now I suppose if you wanted to, you could put all that in your calculator under a square root, and then you wouldn't have to square root at the end. So let's try it that way this time. So we're going to say square root, and then we're going to put all of that in because we know that that's equal to b squared. So let's do it. 8, and there's a parenthesis at front, so we're going to end the parenthesis at the end just to make sure. 8 squared plus 13 squared minus 2 times 8 times 13 times the cosine of 92, and I'm going to end the parenthesis for the cosine and end the parenthesis for the square root. And we get it's approximately equal to 15.5 when we round to the nearest tenths. And then I like to see if that makes sense. Yeah, that would have been the biggest. It's an obtuse angle. There can only be one obtuse angle in a triangle. So this side would have to be bigger than those two, and 15.5 is definitely bigger than 13 and 8. All right, let's try another one. Okay, so the optimal tilt for Cosines' solar panel is between 58 and 60 degrees to the horizontal, and Cosines has placed his solar where I'm supposed to find out if he's placed them at that optimal range. So that means we need to find this little angle right here. So what we have all the sides. So this would be the angle we're looking for to the horizontal. Or maybe it's this one, I don't know. I think it's probably this one because that's the solar panel. So to the horizontal would be angle elevations, but we're going to find angle P. All right, angle P. How are we going to find angle P? Well, we're going to look at the side angle side piece of this, right? But we have that side too. It's important that we know that angle P is opposite the 19. So then we'd say 19 squared on that one side. And then that would be equal to 18 squared plus 20 squared minus 2 times 18 times 20 times the cosine of what we don't know yet. So this is where, when you're solving for an angle, it gets a little bit trickier. So I like to figure these parts out first when I'm doing that. So I'm going to go 19 squared, especially when you're first starting it. I mean, when you get really good at it, you might not need to do that, but I'm going to do that and show you. 324 plus 400, and then 2 times 18 times 20 is 720 cosine of P. So if you remember when you solve equations, you've got to get rid of the things that are added or subtracted first. So this is 724. So I'm going to subtract 724 from both sides. And when I do that, what's going to be left over here is a negative 720 cosine P. What most people do wrong is they subtract the 720 from this. And you can't do that because there's not a plus or minus sign here. This is a coefficient. So if I had 3 plus 4x, you wouldn't say that's 7x, or you wouldn't subtract 7 and think that those were both gone. So you can't do that. So that's why you have to do it this way. So 361 minus 724 is negative 363. And now I can go back and divide by negative 720. So I'm going to take that and divide by negative 720. And I get that the cosine of P is equal to 0.504166 blah blah blah. I like to leave that in my calculator because this is so sensitive right here that 1/10 is completely different. So I'm going to now use my cosine inverse of P, to find P. So I'm going to put that ratio in there. So I'm going to tell my calculator to take the cosine inverse of that. So I'm going to say inverse cosine and then second answer, and then it'll do that for me. So then I know that angle P is approximately equal to 59.7. So we were told that he needed to put them between 58 and 60 degrees. And it looks like he did. So yes, we would say he has it, because if we rounded that to the nearest degree, it would be at 60. So he is good. Right, last one for law of cosines. So let's mark our stuff again on our picture. Always try to do that. So notice here that they didn't give us any angles, but we have all the sides, and we can still, with side, we can use, we can't use law of sines because we need at least one angle, but we can use law of cosines. So if you keep that in mind, if you have a side, angle, side, which we were talking about, or side, side, both of those are optimal for law of cosines and not law of sines. Alrighty, so let's set it up. It tells us to find angle A, so I know I'm going to have A squared first, right? That's because it's opposite A. So A squared equals 32 squared plus 30 squared minus 2 times 32 times 30 times the cosine of angle A. And so again, I'm going to need to get those on the other side. So I like to 28, sometimes this is what I do, 28 squared minus 32 squared minus 30 squared. So I just do that in my calculator so now I know what the left side equals. So the left side equals 1140 negative. And now I'm going to do all that too. 2 times 32 times 30. And that equals, I didn't use the negative, so that's why it's positive there. 1920 cosine of A. And then I have to divide by negative 1920. So negative divided by negative is going to cancel out. So I'm just going to say 1140 divided by 1920, and I get 0.59375 equals the cosine of A. So I need to use my cosine inverse function again. So the cosine inverse of that guy is going to equal angle A. So I'm going to say inverse second function cosine, second answer, and that is going to get me that angle A is approximately equal to 53.6 if I round to the nearest tenth of a degree. Okay, that's law of cosines. Good luck with that. M squared signing out.